Okay, just a second, just a second. All right, okay, good. So, for the final time, can I confirm that you can hear me?
Yes,
All right,
doctor.
okay, good. All right. So, my apologies for some technical glitches just now. And also my apologies that I have to start at 5 something rather than at 4. Um, One of the reasons is that I think I will give you more time to for self study rather than just listening for me for 2 hours. And can you check your timetable whether there is another slot for me next week, or this is the only slot that I have for you? Hmm. Can you confirm, or nobody knows? No worries. Okay. So the topic for this right, and this thing come again here, so I need to move this thing here, right, and move oops, slideshow, and then display setting, and swap presenter slideshow. Okay, right. And now I can see the chat box. Okay, now I can see it here. All right, so welcome to another lecture, and the lecture for today is such structural equation modeling. Okay, structural equation modeling. And my name is Kamarul Imran Musa, and you can call me Kim. Okay, Kim. And I just noted that there is no more week for me next week. So what I'm gonna do is I'll send you some links for the practical. Okay. So for today there will be only lecture. So again, the topic for today is structural equation, and I'll try to finish by 6. Right. So the teaching plan, okay, the teaching plan. So there will be a lecture, 30 minutes. There will be a self-study for 1 hour, and there will be a structural equation modeling practical using R Studio Cloud. But self-study and some practical, you can do that on your own. So if you look here, and the link for this plot is given down there. This is a hypothetical structure. Okay, a hypothetical structure of sleeping problems. Okay, sleeping problems. So the researchers thought that okay, maybe a sleeping problem could be divided into two two components. Okay, two components. First, the insomnia components, and second, the lassitude component. Okay, the lassitude component and the insomnia components. However, the researchers did not have proper measurements of insomnia and lassitude directly. Okay, they couldn't measure directly insomnia and lassitude, but in their opinion, Sleeping problems could be due to insomnia problem and lassitude problem. So what they did was that they took some measurement that will be representative of insomnia and representative of lassitude, something that they could measure. And the thing that they could measure was sleep quality, sleep latency, sleep efficiency, daytime dysfunction, and hypersomnia. Okay, so these square brackets, the variables, uh, drawn as square brackets, are basically observed variables. And the three variables here, sleep quality, sleep latency, and sleep efficiency, represent insomnia. And insomnia is something that the researcher was not able to measure directly, and because of that, this is represented as an ellipse, okay, or a circle. Similarly, for lassitude, the researcher were not able to measure directly lassitude, but what they did was they measure daytime dysfunction and hypersomnia, because they thought that these two variables, or these two observed variables, were representative of lassitude. Okay, so what you have here is a model, a structural equation model, where you have two latent variable and 1, 2, 3, 4, 5, 5 observed variables. And you could see arrows coming from insomnia to sleep quality to sleep latency to sleep efficiency, and from lassitude to daytime dysfunction and hypersomnia. So this theoretical framework is the one that drive the structure equation modeling. Okay, right. So as I mentioned before, the insomnia and lassitude are two latent variables. Some latent variables are variables that you could not measure directly. You could measure sleep quality, sleep latency, sleep efficiency, and daytime dysfunction and hypersomnia. And you measure these five variables because you thought that these five variables represent those two variables that you could not measure. All right? Right. On the other hand, you have another model, okay, another analysis, which is called as exploratory factor analysis. Okay, exploratory factor analysis. In exploratory factor analysis, you collect data from variable 1, variable 2, variable 3, 4, 5, 6, 7, so on and so forth. And after that, you run exploratory factor analysis to identify which variables belong to which factor, which variables belong to which factor. For example, um, variable 1, 2, 3, 4, 5. Okay, the relationship between this variable and factor A and factor B will be calculated, and after that we will measure the factor loading. Okay, factor loading, and we will look at for example, variable 1, 2 and 3 have factor loading, highest factor loading to which factor? Factor A or factor B? Okay. And for example, we can come out with variable 1, 3, and 5 have a high factor loading with factor A, and variable 2 and 4 high factor loading to factor B. And because of that, you could think that variable 1, 3, and 4 represent factor A, and variable 2 and 4 represent factor B. Again, these are square brackets. It means that you could measure, or you measure this variable, and these variable are circles, because you could not measure them directly. You could measure this indirectly by measuring these variables. Okay, so this is a factor analysis, exploratory factor analysis to be exact. So it is used to search, okay, to identify influential underlying factors or latent variables from a set of observed variables. Okay, you have variables here, maybe 20 variables here, and you run exploratory factor analysis to identify from these 20 variables how many factors can you identify. Oh, how many factors can you identify, and in each factor how many variables will come in, right? So what is the motivation of doing this? Okay, what is the motivation of doing this? The motivation for exploratory data analysis is to, to try to simplify the order of the relationship between variables. Okay, that's number one. And number two, we can use exploratory factor analysis to explore, okay, EFA, explore what? Explore possible underlying factor structure from a set of observed variables without imposing a preconceived structure on the outcome. It means that you don't commit yourself how many factors will they be. Okay, what you have in hands are 20 variables, and you just run the analysis and you let the analysis decide for you how many factors will it generate from that 20 variables. Maybe 2 factors, maybe 3 factors, maybe 6 factors. Okay, so by doing exploratory factor analysis, you don't commit yourself. You let the analysis run its course, and from there you identify the hidden factor structure. However, in confirmatory factor analysis, which is also a statistical technique, this is different. Okay, this is different from EFA, because now you use the analysis to verify, to confirm the factor structure of a set of observed variables. It means that in confirmatory factor analysis, the researcher already has some kind of hypothesis of the relationship. It means that the relation said variable 1, 3, and 5, this latent factor will generate or will exert its cost through variable 1, 3, and 5, and the other latent variable will exert its cost through variable 2 and 4, for example. Okay, so in confirmatory data analysis or confirmatory factor analysis, the researcher already has the framework Okay, for example, this kind of framework, he's got this identified or written down explicitly. Okay, what the researchers are doing now is just to run the test to see if the proposed structure or the proposed hypothesis makes sense or does not make sense. Okay, so to do this, the researcher must use the knowledge from the theory, from empirical research, or maybe both, to postulate the relationship prior or before they run the analysis. Okay, exploratory factor analysis, you run first and then you identify the structure. In confirmatory analysis, you identify the structure first and you run the analysis. What kind of scenario that we can, apply CFA and EFA? Okay, because sometimes these two can exist together. Okay, this is one possible scenario. Let's say you want to develop a measurement instruments. Okay, measurement instruments. For example, you say I want to develop satisfaction scale, attitudes toward health, customer services questionnaire. Then you develop this, blueprint, and then you write the questions, you determine the scale, you test the instruments, you collect the data, and then you run the analysis. And because you have identified the structure, the instruments, and the hypothesis, now you have done CFA, confirmatory factor analysis. And sometimes you proceed with exploratory factor analysis because you think, okay, I've got the hypothesis just now, but could I open to some kind of opportunities? Maybe I would like to see if there is or there are other possibilities of different structure as compared to my proposed structure. So after you have completed CFA, you may do exploratory factor analysis, and from exploratory factor analysis, you may identify new factor structure. Okay, so uh, sometimes CFA can happen on its own. It means that in your study, you have decided that I want to do CFA only. In some other study, you may say, I just want to do EFA only. But in other study, you can do both. Right. What is the relationship between confirmatory factor analysis and structural equation modeling? In fact, structural equation modeling is an umbrella term. Okay, it is an umbrella term. And then CFA is a measurement part of SEM. Because CFA will be able to show the relationship between the latent variables and their indicators. Okay, remember this one? These are the latent variables and these are the indicator variables, and you could see the relationship, okay, from the arrow. Right, so this is, so the arrow, the arrow that you see, that uh, the tail and the head of the arrow pointing towards something, it means something. Okay, it means something. Okay, you cannot just simply put the arrow as you like. Okay, the arrow points something, it has this cause and effect relationship. So that comes under path model. Okay, path model use lots of arrows, and it shows how the variables of interest are related, from which variable to which variable, from which variable to which variable. So you better be careful with the arrows that you are drawing, okay, because they mean something. Analysis of exploratory factor analysis, okay. Actually, EFA is also a statistical technique. Okay, it's also a statistical technique. So we can use EFA to reduce data to a smaller set of summary variables. For example, just now we have 20 variables, and we say that, oh, that's too many. Can I do EFA so that I can group these 20 variables into 3 or 4 or 5 groups only? So you can do EFA, and by doing that, you can reduce the data. At the same time, you can assume or hypothesize the theoretical structure of the phenomena. Right. So methods that can be used for EFA includes a principal component factor analysis. Okay, principal component factor analysis, and also other common factor analysis. So this is one example of how you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you say to yourself, can I group this 10 variable into maybe 2 or 3 or 4 groups only, rather than having 10 variables in my model? Can I group them into similar groups so I can reduce the number of variables? Yes, you may do that. And in fact, from this EFA, it appears that 1, 2, 3, 4, the 4 top variables has or have similarities and can become factor number 1, and variable 1, 2, 3 can become factor number 2, and variable 1 to 3 can variable 1 and 2 becomes factor number 3. So you have, so out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now you can reduce the structure from 20 to only 3 similar groups. And what happened to the last one? It does not load well on factor 1, nor on factor 2, nor on factor 3. So you might say to yourself, could I remove this variable, because it is not specific to any factor. So maybe I should remove it from my model. Right. So again, when we go back to so again, this is EFA, exploratory factor analysis, and coming back to structural equation modeling, it is a family of related statistical procedure, and other names include covariance structure analysis, covariance structure modeling, analysis of covariance structures, or latent variables analysis. And again, SEM is a confirmatory factor analysis, even though okay, I won't go to even though, but SEM can be viewed as confirmatory factor analysis. So what you do for SEM is you want to confirm your hypothesis of the structure that you have in hand. Okay, in your brain, or on paper you have this structure. You want to confirm whether they make sense or not in layman word, or consistent with your model or not. If they are consistent with the model, good. But if your hypothesized structure is inconsistent, what should you do? Should you abandon your model and say that, okay, that structure doesn't make sense, inconsistent, you know, or should you modify the structure, from having, you know, two, then you may have another one, or from two can you have only one letter structure, and from three maybe two here, this one goes to there. So you can modify, or should you just say, nope, this model does not make sense, does not fit the data, so my hypothesized structure of insomnia and lassitude is not correct. Right. So, why do we require SEM? Okay. We require SEM because we need to, test the quality of the outputs from SEM. Right. Um, we want to check whether our idea of structure is valid or not. Is valid or not. Okay. Um, does a model represent prediction that are appropriate with the collected data or the observed variables, or it's just something that you think makes sense, but it is not supported by your data, right? Okay, sometimes you think that, okay, I think that this is due to this, due to this, due to this. You run SM, and SM says nope, the model is not valid. It does not correlate with the data that you have collected. This is another example of structural equation modeling, where you hypothesize. Okay, you hypothesize before you do the analysis. This kind of structure where you have two latent variables. Okay, two latent variables. Latent means you could not measure, and 1, 2, 3, 4, 5, 6, 7, 7 observed variables in square brackets, okay, in squares. And you hypothesize that scale 1, 2, 3, and 4 basically reflects intelligence, and scale 5, 6, 7 reflects academic performance. And you also hypothesize that intelligence will lead to academic performance, and so on and so forth. So the arrow means something. Okay, the arrow means something, the direction of the arrow. So you need to run this model, or this hypothesized model, inside SEM, and SEM will tell you whether this hypothesis is valid or not valid. All right. So again, these are the latent variables, and the squares are the measured or manifest or indicator variables. These are the residuals or variances. Okay. Um, what do we need to perform SEM? Of course, you need to have observed data. For example, you have to have observed data, and you have to have latent variables, latent variables, the hypothesized unmeasured group, and the observed variables can be categorical or continuous. But at the moment, when we mention SEM, it always deal with continuous latent variables only. So based on this lecture, and some of the readings that I have provided in the slide later, in the next slide, you have to ask yourself, number one, when will I need SEM? Okay, when will I need structural equation modeling? Are you clear on that or not? Number two, what should I have to run SEM? What things should I have? What variables should I have? What kind of data should I have to run structural equation modeling? Thirdly, are you familiar with all the terminologies used for SEM? Latent variables, indicator variables, observed variables, variance, path model, so on and so forth. And next, what are the tools that you can use to perform SEM? And I think maybe instead of just focusing on SEM, also, answer these questions for exploratory factor analysis. When will I need to use EFA? What should I have, or what should I get to analyze EFA? What are the common terminologies for EFA? For example, factor loading, for example, eigenvalues, so on and so forth. And what are the tools that you can use to perform EFA? There are three excellent resources, that you could refer to. In fact, these resources on YouTube are actually much better than my lecture, right? So you should watch part 1, part 2, and part 3 at least, um, to really understand, or not to really understand, to have some basic understanding of EFA and of confirmatory factor analysis and structural equation modeling. So these three lectures um, were delivered by Professor Patrick Sturgis. Excellent resources, and everyone should go and watch these three videos. So that's the reason why I'll be quick with this lecture, because I want you to go and watch these three additional resources on YouTube. And I'll and maybe Edward should confirm the next class, if I have, or if I don't have any practical next week or next 2 weeks, or when. If I don't have any practical session with you, then I'll prepare a guide, so that you can go to our Studio Cloud and run or perform SEM on our Studio Cloud. So I guess with that, that will be the lecture for today, and I open the floor for questions.